Right, so next I want to kind of cut off that piece at the bottom. So let's go down here, drop a null, and put an out on this. Let's say out non-active. Control C there. I'll just bring it down here close to that, and then we'll just object merge it up here. Okay, object merge, and then paste it in there. So copy the root, from that null, and then paste it into the object merge there. Okay, and then we're going to be fracturing it. Sorry, not Boolean fracture. We want to the normal Boolean. We're going to be subtracting from this. Okay, but we'll do it piece by piece. It just kind of works out cleaner when you run, especially Boolean over a for each loop. So again, for each named primitive, we've got that class attribute. We don't have name, so class again, because since we have this, okay. So let's visualize the first one. So this geometry goes in there, and this goes in here. So obviously here it's not doing anything, but when it gets to the pieces at the bottom, it will. And we need to be able to, oh, it's already set to subtract by default, okay. Also, I want to fracture up this, the pieces of metal. Okay, so there's kind of two levels of fracturing. Let me set this to the class attribute. So with bendy metal, you have, yeah, as I said, two kind of sections, right? So either my final piece of geometry will be this one green piece here. Let me get another exploded view. So either at the end of the simulation, we deform this yellow piece and this always stay together, or we fracture it down a bit, right? So the idea there is that the metal is, tearing and being pulled apart in the simulation, or we leave it as one big piece. So once you do that, you fracture it again, which is what we'll do in another for each loop, where you have, lots of small pieces which allow it to bend, okay? But you won't see those breaks in the final simulation, if that makes sense, in the final render. Okay, they just allow flexibility, basically. So for this fracture now is the actual chunks of metal. Okay, so I'm going to drop a scatter and a Voronoi fracture down here. Okay, oh, before we do that, because that's going to be 1,000 points going in there, don't think is what we want. We'll use the density again. So turn off force total count, density scale. I'm going to drop that to 0.25. I don't know if that will make any, a few points here. Okay, and then we'll fracture this piece, and then we'll have a name attribute that we can see. So all of these pieces will be constrained together along the borders. And they will never break, okay? We won't allow the solver to break them. So I want to do the same thing here with the global C that we did in the other for each loop. So I'm just going to set this to manual, go into that scatter and copy the expression. Copy that. If you can't see it, by the way, just click on the name of the parameter. Okay, and then I'm just going to paste it in here. So this, be careful here because this is referencing the other node there, which we don't want. So come to the top, create a new one for this for each loop. Okay, and then we got a name there. Okay, so it's for each begin 2, metadata 1, and it comes up there. Okay, this one. Oh, don't do that. There we go. For each begin 2, metadata 1. Okay, and then set this to auto update. Maybe to test it, if we go to the bottom, then go on single pass, set this to 3, let's say, come up here, click on that. That's not right. Oh, if we reset cached pass, Oh, there we go. Now it's working. I'm not sure what was happening there. It was just kind of not being updated. Okay, so yeah, that will give us a different value for each iteration when it goes round, and change the you know, the way the points are scattered. Okay, so that's it. The constraints we'll do later. Oh, actually, in this case, we don't want those constraints. I don't want the pieces there to be stuck together. So run through that, turn off the single pass. Hey guys, before you run through this for each loop, make sure this bowline is plugged in like this. I kind of went all the way through the setup to the simulation before I noticed that I'd missed out connecting that up. So make sure that, so we cut off this piece here. So in the later videos, you might notice that this is not set up and I've got the geometry under here, but I've come back later to do this, right? So make sure that you do that before, you know, having to run through all of this and save it again, okay? There we go. Okay, so each of these will be separate in the simulation, and then we'll, you know, we'll sub-fracture these again. So now that I've done this fracture, I'm going to drop a connectivity sub to update that. So on primitive again, and also assemble it, because the name attribute won't be correct when it's run through a for each loop like that. Okay, and we'll call this metal, and then file cache this. Okay, so frame, save current frame, and we'll save it in geo. Let's do the like that. So metal frac. Okay, save that. Make sure to check load from disk, and you're good to go for the next step.